Okay, this is hyperbola, day 1 notes. The definition to a hyperbola is the set of all points for which this is different. The difference of the distances to two fixed points is constant. Okay, we still have the center at HK. So here's our center on both of them. If you notice, it looks a little bit different. We have this box in the middle, and I'll talk about that in a minute. So we still have an A, B, and a C. So for your A, the nice thing about this is it is exactly the same. So A is the distance from the center to your vertex. So on our pictures down here, let's look at our vertex to the center. That is our A. And over here on our vertical one, A to the center, or center to vertex is your A. Your B is still the distance from your center to your co-vertex. And on our picture, on our horizontal one, this would be your B value. And then over here, this would be our B value. And our C is still our distance from the center to the focus. So this is going to pass this, so this is going to be center to the focus. And this is your C value. And then from here to here, this is your C value. Okay, one other thing that's going to be a little bit different is you still have something that looks like your Pythagorean theorem. So we've got C squared equals, on our hyperbola, it's going to be A squared plus B squared, right here. Okay, so for our horizontal, so our vertex and our focus go horizontally. If you notice, our focus is on the outside, it's the furthest point out. But our picture, if you notice, is out here and our focus is in the middle. And our equation looks very similar to our ellipse. So I'm going to say x minus our center of h squared. It's a difference, so it's minus. And then I'm going to say y minus k quantity squared. And that's equal to 1. This is over a squared. The second is over b squared. So that's our horizontal. Kind of looks exactly like the ellipse. The difference with our vertical, this is where we're going to change on this. Your x and your y are going to totally flip. So I'm going to start with a y minus k quantity squared minus stays the same, x minus h quantity squared equals 1. Your a and your b stay the same. So this right here is what changes, not your A and your B. Okay, so that's what flips. In this case, A is always first. All right, let's try our first problem. So it says sketch the graph, plotting your center and your endpoints, a focus and your slope. All right, so some different words here that you're going to notice. I already have this in my format. I've got, remember, your A always comes first, so this is my A and this is my B, because they're squared. But since I've got my X first, that means this is going to be horizontal. That's what tells me that. All right, so I've got some words here, transverse and conjugate axes. So my transverse is going to be my vertex. Conjugate is going to be your co-vertex. So instead of major and minor, they use transverse and conjugate. I know my A is going to be 3, my B is going to be 4. If I use my equation, C equals 9 plus, remember we're adding, then C squared equals 25. Therefore, C is 5. My center is at 2, negative 1. My vertex. So 2, negative 1, and every time you graph, you label your vertex because you're going horizontally, meaning left and right. I'm going to go left and right 3. That should make this negative 1, 1, and 5, 5, negative 1. Your focus is also going to go left and right, and I'm going to move that with a distance of 5. Remember, your focus is out further. So out 5 from your center is going to give you -3, -1, and 7, -1. Okay, your co-vertex or your conjugate, and I remember this by the co's, co-vertex and conjugate. So your co-vertex is going to go up and down, and I'm going to use my B value, so I'm going to go up and down 4, let's see, 2, 3, and 2, -5. And I'm going to have to find the slope of my asymptotes, and so this is what I need to do from here, and connect all the vertex, and I'm just going to make a box with them. After you make that box, which you saw when I first did the picture, now you can make your slant asymptote. So what you're going to do is you're going to connect the corner with your center and the corner, and do the same thing with your left. These are your slant asymptotes. It's easy with a graph because you can do rise over run. So 4/3. And then if I go opposite, that would be negative. So your slopes are going to be positive and -4/3. If I did not have a graph, this is what I would do. Remember your slope formula. Your slope formula is y minus y over x minus x. I would take my center is 2, -1, and I would take any of your corners. I've just been taking my right corner. So this is 5, 3. So you have 2 points, and you can do change of y over change in x. That gives you a -4 over a -3, which simplifies to 4/3. So your positive slope is 4/3. Your negative slope is going to be -4/3. So this is the information that I'm asking for. In order to draw your graphs, the last step is you're going to go through your vertex. You're just going to draw a sideways parabola here and here. And then you're going through your vertex. Your focus is in the middle of your parabola. Hope y'all can see all that. Okay, let's try another one. So I'm doing the same thing as I did on the previous problem, but the first thing I have to do is complete the square or put it in standard format. So how do I know if I put x first or y first? It's going to be set up. My y is first. So if you're looking at your equations, y first means it's vertical. Remember, you can't have any coefficients, so I'm going to take my y, take out the coefficient, so that is going to be y squared minus 2y, leave a blank. Then I'm going to take my x's and do the same thing. I'm going to factor out, it's basically factoring out a -9, because remember there's a minus in between your equation, so minus 9x squared. If I take out a 9 from this positive 36, that's going to be a minus 4x, leave a blank. Your 68 is on the right side. Then I'm going to leave a blank for my y's and a blank for my x's. Half box square, and I'm going to put in a positive 1. That's really 4. Half box square, the -4 here, and that leaves me a 4 here. But really this is -36. Then if I write this, that gives me a -4, y minus 1 quantity squared, minus 9, x minus 2 quantity squared, and this equals a 36. Remember, this has to be equal to 1, so I'm going to divide. I'm going to divide by 36, so that would be y minus 1 quantity squared over 9 minus x minus 2 quantity squared over 4, and that's going to be equal to 1. And there's my equation. We already know that it's vertical. And we know that A is first, always, always, always. A is 3, B is 2. If I do my equation, remember adding 9 plus 4, C squared is going to be equal to 13. So C is about, well, it's square root 13. And I'm going to say that is about 3 something. I'm going to round it to like 3.5. Center. This is the hardest thing, or the things that people mess up the most. Your x is second, so this is going to be 2, 1. We're going vertical, so I need to go up and down 3. So this is 2, 4, and 2, -2. Your focus is going to go the same direction. Your focus is going to be 2, 1 plus root 13. 1 plus and minus root 13. So we're going to add basically 3. So I'm going to say like 4. So it's going to go further. So 2, 3, 4, and a little bit more. I'm not sure I can get this in here. So this is your focus. And then I'm going to go down, subtract it a little bit more. Co-vertex. Your co-vertex is going to go left and right. And that's going to be 2. So co-vertex is going to be 0, 1 and 4, 1. Okay, this is when I'm going to draw a box connecting all my vertices. Okay, now from the corner of your box, your center and the corner of your box, that's your asymptotes, your slant asymptote. And so I'm going to go over how to do my slope. I'm going to take my center point, which is 2, 1. I'm going to take my corner, which is 4, 4. And I'm going to do change in y over change in x. That gives you -3 over -2. So that's a slope of 3 halves and -3 halves. So you have to do the positive and the negative. So I'm going to check. 1, 2, 3 over 2. Perfect. And I'm going to draw in my hyperbola with your focus. I'm sorry, go from your vertex. Your focus should be in the middle. And this is a vertical, so that is up and down. And here is all my information. All right, remember your first number is going to tell you if it is horizontal or vertical. And since it starts with an x, this is a horizontal. So factor out an x, or I'm sorry, factor out a 6. That's going to give you 6x, leave a blank. Factor out a 7, that gives you y squared minus 2y, leave a blank. That gives you, move over your 5, leave a blank for your x, leave a blank for your y. Half box square, that means I'm going to add a 9. That is really 54, so add a 54 over here. Half box square, you're -2, that gives you a +1. This is really a -7. When I bring this down, this is 6x minus 3 quantity squared minus 7, y minus 1 quantity squared, that's equal to 42. Divide by 42 so you can be equal to 1. So that's x minus 3 quantity squared over 7 minus y minus y minus 1 squared over 6, and that's equal to 1. This is your standard equation. Remember, A is always first. Okay, this is kind of wackadoo. This gives you a square root of 7. B is the square root of 6. C, that's going to be the square root of 13. So let's do an abouts here. Those aren't really abouts. This is about 2.5. So 6 is going to be a little bit less. So that's going to be that's going to be less than that. I'm going to say 2.4. Okay, 13, we just did that. That's 3.5. Center, my x is first. So that is 3, 1. Vertex, these are yucky. 3 plus or minus the square root of 7. It's easy to write down, just yucky to graph. So it's about 2.5, so that's about 5.5 and 1. Okay, focus. I'm adding it to the front, so this is going to be 3 plus or minus the square root of 13 and 1. Co-vertex is going to be, 2.5, sorry, about 2.4, or less than 2.5. So I'm going to add 2.5 and go a little bit less than that. Okay, so 2.5 is going to be about 3, well, it's going to look like 3.5, and then it's going to look like, what, 1.5? And so my co-vertex is going to be 3, 1 plus or minus the square root of 6. Okay, slope. Okay, let's draw our little box here, connecting the best that you can. And then I can draw my slant asymptotes. All right, so this one is going to be super crazy. So my center is 3, 1. And this point over here, this is the one I'm always picking, is going to be 3 plus root 7. Oh gosh, 1 plus root 6. Okay, so I'm going to do slope over this. So 1 minus 1 plus root 6, and then 3 minus 3 plus root 7. Oh, that turned out good. The 1's cancel, the 3's cancel. This gives you root 6 over root 7. So this is my crazy slope. And let's draw in our hyperbola. So from your vertex, this should be horizontal from your vertex. And there you go.